Hello, and welcome to another episode of Real World Analytics, or What Schools Don't Teach You. This is another installment of my visualization series where I talk about different data visualization techniques I use in my career as a professional data scientist. And today I want to talk about Sankey diagrams, or more generally, flow diagrams. Sankey diagrams are named after the Irish Captain Sankey, who used these diagrams to look at energy efficiencies of steam engines. There are also so-called alluvial diagrams and other names for different types of flow diagrams, but as the function I'll be using is a Sankey function, I'll be generically calling these as Sankey, but don't be surprised if you see other names for them floating around. Wikipedia has a list of different options for making Sankey plots or Sankey diagrams, but today I'm going to be focusing on Google Charts. And if you go to the Google Charts website, it gives some basic examples about Sankey diagrams, and going through different configuration options, such as if you have multiple levels, stitching all the data together, controlling colors, controlling fonts, labels, etc. And it's a pretty good resource for looking at the different things you can do within Google Charts. If you're looking for a more detailed explanation of how I use Google Charts through R via the Google Viz package, I do have a Kaggle kernel that has some different plot options. I'm building these Sankey diagrams using Google Charts incrementally, starting off with the basic and then adding more and more features as I look at different charts. I also have examples from different packages, such as the GG Alluvial package. Remember, Alluvial is just another name for this type of flow diagrams. And Network D3, which leverages D3 to create these Sankey graphs. Now, these can be quite useful, but they're not my preferred method. It's not my preferred method because this doesn't illustrate a traditional flow, in the sense that people who come to click on an ad, there's different ad campaigns, those are the numbers, but from those ad campaigns, they don't really flow into being male or female, and then from an age group. It is quite useful in the sense that if you want to look at a specific group, like women aged 30 to 34, you get that band, and by customizing the tooltips, you can get further information out of it. I prefer to look at information as a flow, and as an example of that, I have data from my own YouTube channel. So here we have a rather large example of a Sankey diagram. This is from my own YouTube channel, starting off with the total number of clicks that people get when they are shown a thumbnail in YouTube. I get a click-through rate for all these different types. And I want to segregate it out by video family because I have different thumbnail structures. So Kaggle is normally a picture of me in the Kaggle code. Coffee series is me with a coffee cup. Other, which this is doing quite well somehow, is me pouring coffee, but that's my channel update. That's the only talk in there. And then on the other side, I have the distribution for how long people are watching the individual videos. And so if I look at something like academia versus industry, unfortunately, this is only average. So I don't know whether that thick band watching medium, if they're all watching my video for a medium amount of time, or if some are short, some are long. I don't get the distribution, but it's not the data I want. But no good data science project would be good if all the data were exactly like you wanted it, right? And I don't think Google is going to go changing the way the data are available just for me. And then to play around the link going from the video family to the specific video, I have made individual Pokemon, because if you're doing something out of work, I think it's worth having something a little fun and to try to test yourself. In this case, I wanted to demonstrate that I could have images in the tooltips, and so I found a way to do that, and what better way to do that than with Pokemon. So that's an overview of how I use Sankey diagrams or alluvial diagrams, and more specifically how I use Google Charts in order to show customer journeys or something. In my banking career, in terms of credit risk, I use these things for customer journeys. If they make an application for a loan, what are the different steps before that loan gets formally approved or rejected? And just as in my gauges video, I encourage you not only to look at the overall numbers of flows, but start adding business metrics, click-through rates, cost per click, sales per click. What are the different metrics, or what are the different points of interest in your stakeholders? And then you can append the tooltip with that information and go from there. But if you use Sankey diagrams or alluvial diagrams, if you have questions about them, if you've shown them to stakeholders and they didn't really understand what was going on, and you've had to help them understand, which I've done before, it can be a somewhat painful journey if they don't want to understand, but the one time I've shown this to a stakeholder who had no idea what he was looking at, or after he looked at it for a few minutes, he could understand the flow and he could understand the insights about what were the critical points and what were the places that had the most impact on the overall journey, the critical path, if you will, for getting a loan application approved. So please let me know if you have any questions. The code and stuff will be up later. I'm preparing a presentation in Melbourne on Google Charts, and once that's done, I'll put up all the slides. I'll update the links down below, and I'll see you next time on Real World Analytics, or What Schools Don't Teach You. Thank you. Goodbye.